So extracts, for people who know, this might be a bit redundant information, but extracts are snapshots of your data which are shown in an optimized format, and that is Hyper. Hyper was acquired a couple of years ago by Tableau and is an in-memory data engine and can empower up to 5 times faster analysis. And I've seen this at clients multiple times, that you're first working with a live connection, and of course there's always distinguishing, or there's difference between use cases where you can use live connection or extracts. But when we extracted the data, and that takes that takes a couple of minutes or hours even, that the performance the performance increase was significant, and was really impressive to see how much faster an extract works than a live connection. And extracted data sources, those are indicated with this little icon where you see a data source or a live data source embedded or transformed into another database. So that is basically the thing that I've just discussed. So you're transforming your data in an optimized format, being the Hyper format, and that is the difference with that icon. Is that so you see the difference with extracted data sources with live data source, where you just have the simple database. And I'm just going to show very quickly how you can create an extract. It's rather simple, and it will take only a minute, but for some people it might be very valuable. There's multiple ways of creating an extract, but if you have, for example, a data source here, in this case, this is the users table of our Tableau server instance of Bistry internal. So you see a lot of data for users. For example, Timothy, Joffrey, the managing partner. And this is data coming from a PostgreSQL database, and in this case we have a live connection, which you will see here on the left-hand side. If you want to create an extract, there's multiple ways. We can select an extract here, and we can even add some filters, which I will come back to in a minute. And then if we go back to users, you see that we've created an extract. In this case, we only have 80 marks or 80 rows, so that will be really quickly, but it can take a certain amount of time when extracting larger data sets. Another way is just when you're creating your reports and you don't want to go into your data source pane, for example, because it takes too long to load, because that can happen as well. Because if you have more columns and more rows, then that can take a significant amount of time. You can just right-click on your data source on the left-hand side, and you will see the same pop-up window where you can extract your data. And I will come back to this in a minute to see which fields here or which options here can also have impact on your performance. I'll come back to that in a minute. Then of course, with everything, there's advantages and there's disadvantages to extracts. So that, I mean, that's with every technology, with every, even with with everything, with data itself, there's also advantage to visualize them in a certain way, and there's disadvantages. So in this case, the advantages are, of course, the performance boost, because we've seen 5 times faster analysis with Hyper format, with the Hyper format. Of course, there's exceptions, and I will come back to that also later. But I've seen cases with Oracle, DB2, SQL Server, Postgres, MySQL, all of these databases where an extract was up to, let's say 2 or 3 times faster than with a live connection. Then the possibility to pre-aggregate. This is really important, because in a lot of cases you have the option to hide certain columns which you don't use, and with limiting the number of columns, you reduce the size of your extract, and reducing the size of your extract has impact on performance as well. So if you limit the number of rows in your extracts, so you filter basically data out. For example, you have transactional data from the past 20 years, and you filter only the last 10 years, so you show only 2010 until date. This will have performance impact, so you will boost your performance as well, because you have less data to query afterwards. But also the number of columns is very important, because if you have 100 columns and you have 1 million rows, then it makes it makes your life a lot easier. Well, not only makes your life a lot easier because you'll have to search through a lot less calculations if you limit them to, for example, 20 fields that you're using regularly. So if you have 100 dimensions and measures together, and you can limit them to 20 or 30 fields, you limit your data set, but also you make life easier for the end users. So yeah, you can do the calculation yourself. If you have 100 million rows or 100 rows and 100 columns, that's 100 times 100. If you do it times 30, it's a big difference in the number of actual cells within your data. And then also you can materialize calculated fields. Maybe that sounds a bit weird, materialization of calculated fields, but materialization of calculated fields is basically creating your calculated field before you extract your data. And if you create your extracts after you've created your calculated fields, then you're materializing them, meaning that you're basically adding them into the adding them into the extract itself. Which means that after you've created those calculations and the extract, when you use those fields in your visualization, the Tableau doesn't need to calculate them anymore. So they're just pulled from the extract. Whereas if you create an extract and afterwards you create calculated fields, then Tableau is creating calculated fields based on the extract, but it's still calculating them in the engine that Tableau is using. So that's quite important. Then next you have your usefulness in published data source. So that is not really related to the performance, but it's still really useful, I think. So if you materialize your calculated fields and you publish your work or you publish your data to Tableau server, and people start creating reports based on that data source, then they have those calculated fields in place, and they don't need to create their ad hoc calculate fields themselves, and you avoid having all these scattered calculations throughout your organization, so that you have one centralized data source with your own calculated fields, which are validated by the data architect or the data builder in Tableau Desktop, and people, end users, who can be explorers, who can be also creators, they can make use of those calculated fields. So that's quite useful, and in terms of data governance, that's also very interesting. But then of course there's also disadvantages. So every use case is different. So you can't always use extracts. You cannot use extracts when you're using real-time data. So you can refresh your extracts every 5 minutes, but if your extract takes half an hour to refresh or an hour, then that doesn't make sense, right? So they're using then you should use a live connection to have real-time data. So for example, if you're monitoring inventory on a minutes base, then it makes sense to use a live connection. Even though you can have semi real-time data when you're using, for example, incremental refresh of your data, and you can refresh it every quarter of an hour, and that's semi real-time data. And then the two next points are known, and that's done by design. Extracts are resource heavy because Hyper was made to consume a lot of computing power. So you might have seen when you're creating extracts on Tableau Desktop that your computing powers or CPU is increasing heavily. It's taking 95% or taken 80% by Hyper, or the Hyper process. So that is a known. That's known, and that's done by design, but know that this can become quite resource heavy. Also on Tableau server, if you're running 5 extracts at the same time and someone else is going to consume a report, make note that this might take a bit longer than when those resource extracts wouldn't be running. So extracts are very resource heavy, and then also extracts can become very large in file size. When you have an extract with multiple columns and you have millions of records, then those extracts can become a couple of 100 megabytes or even gigabytes. So make sure that you take this into account. And then what I've discussed a couple of minutes earlier, you can limit both number of rows and the number of columns, and make use. And I'm really really stressing on that. Make use of that functionality, because extracts are very performant, but even if you're working with 100 columns and millions of records, then still that is quite a lot of data to consume. So make sure that you limit the data only to what you need. So only the years that you need, for example, and only the columns that you need. And then after you've hidden those columns, you could pre-aggregate that data. I'm going to show that like I did before in this view. So for example, if I were to say here, extract the data of Tableau server users, then I could say aggregate data for visible dimensions. And in this case, it will aggregate everything. Well, aggregate for all of the dimensions. But if I were to say hide all unused fields and then extract, then you see that only in this case a friendly name has is there. And in this case, we still have 80 rows, but your data, your extract is very limited. So if you're, you can do it this way, and that is the automatic way to do it. So you can use hide all unused fields. So that is basically when you're creating a report and you used a certain amount of calculations or a certain amount of measures and dimensions, you could use this option. But if you're creating a data source like I was doing here, that makes sense to hide them. Let's see, to hide them manually and then creating the extract. So if I create the extract now, you'll see that those fields are back into place. So hiding fields removes them from the extract. That's basically the key point.